In this lesson, we're going to discuss data encryption levels. Data encryption is the process of converting data into a secret code to prevent unauthorized access. By doing so, data encryption ensures the confidentiality, integrity, and security of the information, even if the storage medium or communication channel is being compromised. Now, when it comes to data encryption, data can be encrypted at different levels, including full disk encryption, partition, file, volume, database, or record level encryption. Now, first, we have full disk encryption. Full disk encryption, as its name suggests, encrypts the entire hard disk drive or storage device to protect all the data being stored on it. For example, on a Windows-based system, you can use the software full disk encryption tool known as BitLocker to encrypt the entire contents of your hard disk drive or solid-state device. When you boot up your system, BitLocker will require the use of a PIN, a password, or a security key to ensure that even if your storage device is removed and accessed from another system, your data will remain securely encrypted and safe from prying eyes. If you're using a Mac OS system, on the other hand, you can use FileVault for this same purpose. Alternatively, some storage devices will also have hardware-level full disk encryption embedded into them as well. Second, we have partition encryption. Now, partition encryption is similar to full disk encryption, but it's only going to be applied to a specific partition on your storage device. For example, if you use a software tool like Encryption, you can choose to encrypt only the partition containing sensitive documents while leaving all of your other partitions, like the operating system partition, as an unencrypted partition. Now, you may wonder why we wouldn't just encrypt the entire drive instead of only encrypting a partition. And the reason here is that encryption does add some extra overhead to the process of reading or writing data to a storage device, because now we have to decrypt the data being read or encrypt the data being written. So, a lot of times, we will choose just to encrypt the portions that contain sensitive data because this will speed up our overall system. Now, third, we have volume encryption. Volume encryption is a technique that's used to encrypt the set space on the storage media to create an encrypted container that can house various files and folders. Now, Encryption is a common tool for creating these kinds of encrypted volumes, and this method provides us with flexibility because we can decide the size of the encrypted volume that we want to use. This allows us to have this as a secondary form of encryption that can be used in addition to a full disk encryption system. This way, we can allow the entire disk to be encrypted using full disk encryption, and then use a secondary partition that might contain some more sensitive data that's also going to be created and encrypted using a volume encryption tool like Encryption. Fourth, we have file-level encryption. File-level encryption is used to encrypt an individual file instead of an entire partition or an entire disk drive. Now, for example, let's say you're using a software tool like GNU's Privacy Guard, also known as GPG. You can do this to encrypt just the specified files you want, and now you can send those files back and forth to your coworkers over email and not worry about any attacker being able to read them because these files are fully encrypted. Now, this method is really useful if you only need to secure a few crucial files rather than your entire disk, or you want to be able to encrypt a file before you send it off of your system to some other person. Fifth, we have database encryption. With database encryption, your entire database is going to be encrypted, and this is similar to conducting a full disk encryption, but this actually can span several storage devices or a cloud-based storage environment too, because our databases are often stored across multiple data sets. For example, you might have data encryption using the SQL Server Transparent Data Encryption, or TDE. Now, this type of database encryption will automatically encrypt the entire database and requires no changes to your underlying application because all the access to the data is happening by the database system, who's taking care of the encryption and decryption tasks on your behalf. Sixth, we have record-level encryption. Now, record-level encryption is used to encrypt individual records or rows within a database. This is a more granular method, and it provides flexibility to encrypt only specific data within a database. For example, inside of your customer database, you may only encrypt the columns containing sensitive information like their credit card number or their social security number inside of the database instead of having to encrypt the entire database. So remember, data encryption can be applied at various levels, including full disk, partition, file, volume, database, and record-level encryption. Each of these provides a different layer and granularity of security, so it's important to understand the differences to ensure that you can select the right balance between security and system performance when you determine which encryption type you want to utilize in your organization. Data encryption does require thoughtful planning, implementation, and ongoing oversight. Our objective here is to ensure that your data remains secure and inaccessible to unauthorized entities, regardless of where that data is actually going to be stored.